Talking AI with Mads Torgersen.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence, all while using everything that AI and the .NET ecosystem has to offer. I have a returning guest today on the show. It's Mads Torgersen, back from episode 325. We were talking about C# and languages and other things. But Mads Torgersen is a principal architect at Microsoft, where he's been for over 20 years, and he's been the lead designer of the C# language for a long time. And prior to this, he was a professor and contributed to a language that happened to start with J at the time. And he was previously on episode 325 of the podcast. You can look for that in the archives, where we were speaking about the latest in C#. So Mads, welcome back to the show. How are you, sir?
Thank you very much. I'm doing very well. Thank you. How are you?
I'm great. I'm glad to have you back on. And I want to kind of catch up with what's been going on since we've had you on the podcast last. But for the new listeners on the show, maybe they haven't seen you speak before or just recent to the podcast, I always like to ask, going back in time, you've been kind of working on languages and just in software engineering for a long time. What do you think is the spark that keeps you interested and engaged in this work in general?
It's not one spark, I think, for me. It's a confluence of two or three things that combine so very well for me personally that I can't help but have a good time. One of them is that I am nerdly interested in programming languages. They just tickle my brain in a wonderful way. Languages in general, actually, but programming languages in particular. And another one is that I get to work with people that are amazing and that, like me, like to lean into exploring the possibilities and thinking out the unexplored spaces and so on. So it's, just the people side of it, that's like my everyday colleagues as well as the community. And I think the third thing that also really honestly makes it tick for me is the impact. It's that what we do impacts, hopefully in a good way, millions of people. And that's exciting, and it gives it kind of immediacy that I like.
Yeah. Well, someone in your position where you work on C# and it's the primary language of the .NET runtime, and then Visual Studio is all about building applications with it, and then so many people worldwide use it and have kind of learned this language, and there's millions of lines of this code in source code repositories all over. With I would say the last year, but probably just since the Build conference last May, when the Copilot agent mode came out, and of course Cursor and Claude and Codex and Gemini. There's a lot of people asking the question, okay, are we writing these languages? So in your mind, this industry change, how do you interpret it, and how do you make sense of what's going on?
I mean, that's a great question, because I think this is one of those situations where so many things are up in the air that you can't really just select a viewpoint and settle on it. You have to constantly reevaluate and readjust and so on. And the same goes for its relationship to programming languages, which is where it impacts me professionally. It's amazing what has happened, as you say. The amount of given a high enough token budget, the amount of stuff that an AI can do for you in code with quality and seeming insight and so on, it's just gone through the roof. And it's really, really baffling and amazing in many ways. It's also still amazingly stupid in some ways, and you can't always predict which one it's going to be. But clearly, this technology is proving itself now. Like there has been a lot of skepticism. There's both like sort of moral skepticism. I don't know where that lands, but also it's a fad kind of skepticism. Like it's going to quickly run out of steam. There's going to be a limit to what it can do. Well, that may be at some point, but we are certainly not anywhere near that point yet. So from a language point of view, we have to think about, well, how does that impact now that humans aren't the only ones writing the code, but there are these software programs writing
these
programs,
bots.
Bots. What does that mean for programming languages? There's been these, in the early days, I'm not hearing it so much anymore. There were a lot of people that were like, compilers are a thing of the past, programming languages are a thing of the past. Give it a few years and the AIs will just be generating machine code directly. Why, just cut out the middleman. That's much more efficient. Who cares? No one's going to read the code anyway. And I think it's turning out very clear that is not the direction we're heading in. Maybe one day, many years from now. But one of the things that's becoming really, really clear is this, is the importance of this split between the deterministic world of compilers and algorithms and the non-deterministic world of artificial intelligence, of large language models and so on. And if it was all just about productivity, just producing oodles and oodles of code, we could probably just let the AIs go and do their thing. But it's also about trust. It's about things doing the right thing. And it's about performance. It's about things doing it efficiently and so on. And who's to say that the thing is the right thing? And who's to say that it's correct and so on? So we are now in this, so we're realizing that parts of the deterministic side are indispensable and actually really helpful, not just to kind of counter the wild unknown that the AIs are operating in, but actually help them out. Like the more we can get these sides to collaborate and each contribute their strengths, the further we can go with this and still, have outcomes that have quality and that we can trust and that are like, that we humans believe in as the good outcome, right? So we're constantly working through new challenges by negotiating that line.
Yeah. So you mentioned the point, nobody knows where it's going to go. And we can dispense with the futurist what if, because I don't find that very interesting. But even if the current models stopped innovating and all we had were the ones that we have now, boy, is that useful. I mean, and even right now, what we can do. And so what seems clear to you, right now with the current state of the technology and where, your team is implementing it and where you're encouraging people to implement it? What low-hanging fruit do you see or maybe obvious scenarios right now?
Well, I like to compare it to a few other turning points in my field's history, right? There was the advent of high-level programming languages. Like actually, that sort of, once people started to trust, yes, the compiler will generate good machine code. You don't have to hand tinker with the machine code in order to optimize it enough, Once people started trusting that precipitated a step function in productivity that meant not just that you could write code faster, but that there were more things you would address with programming in the first place, and the whole field grew. And then there was a similar step function when IDEs became a thing, or, code editors, smart code editors, whatever you want to call them, where the loop that as a developer I was in, where I would try writing something and then I would wait for the compiler and then it would come back and tell me, you have an error there, there, and there, figure it out. To where something at my fingertips while I was writing knew the syntax and semantics of what I was doing and could give me real-time feedback. It could give me a squiggle as soon as I made the mistake, or even like give me completion, so I never even made it in the first place. And that was another step function. And in productivity, that really, really moved the needle, and actually moved the needle somewhat on programming languages as well, because we have gradually started, as language designers, we've gradually started to assume that people have a tool that can tell them things that aren't evident from the program. Maybe you don't need as many explicit types anymore because you can just hover and then it'll tell you. And then it's nicer not to have them cluttering up your source code. Now, AI is the next such step function, right? It can write code on its own, and it can understand and modify and act on code in ways that, have never been possible before. And we can certainly harness that for another productivity gain. And I think one of the interesting, like I was talking about negotiating that line, one of the interesting things that we're starting to realize about AIs is we've actually been, for the first couple of years of like agent coding, we've been putting them in a pre-IDE situation. Like the context we've been putting them in, that it's all that there's even an internet, but we certainly haven't given them a tool at their fingertips where they can ask the deterministic algorithm very cheaply, am I on the right track? Or tell me what my options are here, and in a way that I can trust. And that's one of the many evolutions that's happening now, is that we're thinking, well, if that was good for humans, that's probably good for AIs too. Let's enable, like sometimes people talk about it as in terms of enabling the LSP, the language server protocol, which is a standardized protocol that IDEs use to talk to language servers, which are essentially compilers that are sort of ready to answer questions about the code. And what if it was as easy for an AI to ask an LSP a language question as it currently is for us through the visual UI? And people in many places, including Microsoft, are leaning into what can we, how can we optimize around that one? And now all of a sudden, the AI gets the same productivity boost and the same confidence boost and the same kind of quality boost that we all got from IDEs 20, 30 years ago. So it's very exciting.
Yeah.
And there is very clearly, this is happening. What lies beyond that is anyone's guess. But this kind of stitching together of the best of the deterministic compiler side and the AI side is happening right now, and it's really almost promising to boost the quality and experience and outcome of agent coding as much as the improvement in models.
Right. Well, in some of the conversations that I've had, with those of us that have a little bit of gray hair and remember some of the other transitions, like you mentioned, the high-level programming languages, and then I personally never worked in anything but high-level programming languages for real, except for education. But the whole move from mini computers to desktop computers to the internet to mobile and the cloud, and then ephemeral environments, DevOps, every transition, there were people that said, no way am I going to do that. You want me to connect every computer to a network? Why would I do that? Or with the DevOps movement, you want me to let an automated script have access to my production environment, and the script is just going to deploy to my production database, my production environment? No way am I going to do that. And now we look back and we consider a human doing a production deployment by clicking, copying, and pasting. We consider that malpractice. So now with this transition, the question is, okay, what emotional responses are, no way I'm going to do that, versus, fast forward some years down the road, we look back and say, what? You're doing that task manually? That's malpractice.
Yeah, we're touching on the question of trust here. And that's a thing that I think that question you're right, it's come up with every transition. Like, I don't trust that thing to do the right thing. I think the question is somewhat uniquely framed for AIs because they are non-deterministic in this new way. And so part of the reason why people got over their trust issues with many of the other transitions is that there were tools built that were, because they're deterministic, they can gradually prove themselves or be like formally proven even they're doing the right thing, and even then, of course, everything's subject to attacks and malicious whatnot. But we've learned to grow our sort of trust system to incorporate those things. And I think it's it's still like work in progress, how we do that as we let AI do more and more things. Because it has this non-determinism at its core, it might just do something different tomorrow than it did today,
Mm-hmm.
And no one can really say, why did you do that? And it makes these mistakes that are spurious and learning to deal with that, building a trust system that helps us deal with that. Like maybe in the wider world, that's a little beyond my pay grade, but certainly in the scope of programming, that again, that's something that needs to grow with it. And that by its nature is kind of like always limping a little behind when things are moving fast. So,
Mm-hmm.
so I think you want to look to, I think when people are thinking about their investments here, you want to look to where is trust taken seriously? Like who's mostly bragging about the wild things it can do and who's actually talking about trust as they are rolling out AI-based technologies.
Yeah, that's a good point.
Yeah, that once again, that is a thing that needs to mature, and it behooves people to kind of keep an eye on what is at stake and what risks they are willing to take as this technology evolves. But then I think by the very necessity of it, I mean, we're not going to end up in some. I don't think there are many apocalyptic ways that this can end, but I don't think one of them is that we all kind of lose this battle somehow and we can no longer trust code. Like that there is going to be a trust model. Maybe not everyone will follow it. Maybe not everyone will care about it. Maybe there will be disasters because of that, but we will mature trust around AI coding as well.
Well, that makes me think of how we come to trust just any other way that a piece of software might change. For example, there's people committing to the actual code for the C# language and then for the runtime. You get a new engineer on the team. At some point, you have to ask, okay, when do I let them make a change? But then there's the feature branching and then the automated tests. And then it's like, we never just, oh, I trust you, therefore, go ahead. It's not, even if I think I trust you, you still go through the process that we have formulated for ourselves and then merge it into master and then do additional testing and then our release process. And it's almost like we don't decide that I think that they're going to do a good job. We still put them in the process where when they make a mistake, we catch it.
Yeah.
Right?
Yeah, I think that's true. I really like that framing. We already have a system where we assume that people make mistakes. It's not even about malicious. Like we just assume, and we know we all make mistakes.
Yeah.
And we all have an interest in those mistakes not blowing up. And so we build systems around catching those mistakes. And that makes us all feel safer and also feel more emboldened to do great things.
Experiment.
Right? We experiment and lean in because we know that most mistakes are going to get caught down the line. So yeah, we already have that kind of built in. But one thing that's a bit of a challenge is that AIs do it so fast. And, part of what we rely on, certainly for very high stakes code, is human code review, right? That's one of the major stopgaps in our process, most of the time. And as we start having maybe 10 times or 100 times velocity on the code changes, then how do we keep up with the same level of trust if we have the same level of human review involved,
Yeah.
right? What did we just like create this massive bottleneck? So we have to find out how can we also optimize the review side of things more. Like a lot of developers say anecdotally, I hate doing code reviews. It's the least favorite part of my job because it's someone else's code and I have to expend all this mental energy to put myself into it and so on. I think there are many improvements that can be made both around what needs human review and how efficient human reviews can be, and how dare I say, joyful they can be. Right? So we need innovation on that side as well. A lot of that innovation is going to involve AI as well, while at the same time keeping in mind that having AI check the work of AI, it's not entirely stupid, but there is a little bit of a trust issue involved there that we have to is it going to make the same mistake when it evaluates as it did when it coded? Is it?
Mm-hmm.
So again, an interesting field and one that is.
Well, with your position, you kind of understand the internals or the architecture of this new technology and how it impacts the systems that we're building. And so I was wondering if we get an insight in how you think of it, because there's all these concepts. You have the actual model, which almost none of us run any of those on our computers because the useful ones are these massive files and expensive licensing. And then you have the co-pilots and the open code and the cursor, the programs we can run locally. And then you have things like GitHub coding agent and then these helper prompts, or you call them skills or whatnot. There's all these concepts, and I think a lot of people have a struggle kind of building a mental model of what is the architecture or the relationship? What are the pieces and how do they relate? And which ones are likely to be around a long time to come? Like SQL Server's been around a long time to come, but UI libraries that we used 10 years ago, 15 years ago are gone. So what part of the architecture just naturally has all this churn, and what part of the architecture is the core that's kind of the foundation?
Well, it's very generous of you to think that I have big insights into that. I think that, sometimes a picture emerges that is we start to rely on a little more. In the beginning, we didn't talk about agents, and then we did. They seem to be here to stay, and so on. But a lot of what you see now, we have tools, and now we have skills, and they're all these attempts at filling a gap that's currently there in the experience, and seeing is there a next level that we can take this to, and how can we do it? But understand that this is not something people have thought deeply about for years, like a language feature in C#, because we gotta go. It's now, so it's slapped together, and it's smart people usually slapping it together, and sometimes it's a little random which thing gains prominence over which other thing in the industry, and which thing gets de facto standardized versus being in a race for a long time between different approaches and so on. But I think the only thing you can trust is that most of those aren't going to look like that even a few years from now. When we're on the bleeding edge like this, there's a lot less that you can trust. And I can't really help you. I'm saying we're doing our best, but we're also in a mode of not even with novel pace innovation, innovators have to be really careful that we don't kind of marry our existing innovations and lose the sort of psychological ability to drop it for the next thing that is better, right? And at this pace, well, I guess the good news is that we barely have time to get attached to something before it's obsolete, so we don't end up loving it so much. But it's a difficult time to navigate when things are so much up in the air. It's important to remember that all of this is optional now, right? You don't have to use AI for everything yet. You can hang back and even if you draft by 6 months or a year, in terms of how you think about it, you're still, maybe you're a little more insulated. I don't know, but at the end of the day, this might all look completely different a year or two from now. And if it looks different, it's because we found something better. Like we as an industry found something better, and it should look different. But it's hard to be a consumer of those technologies in such an environment. And there's nothing I can do to help you. That is the pace of innovation, and that is the amount of uncertainty that we're all faced with in this phase of our lives.
Well, there's a lot of conversations that I have where people are trying to make sense of it, and then I talk about, well, in the high level, we've always looked at what computers can do, and we've always asked the question, hey, what else can I get this computer to automate for me? And now we've got some more tool belt where the answer to that question now can be different. It's like, I can get the computer to do this automatically for me now. And that seems to be, what's happening. And so with C# and being that the language that, and Python and TypeScript and all that, those are the languages that go into our Git source control. Is there any conversations about that actually changing to be something else that is the files that get put into source control? Or for now, we say, you know what, no, high level languages, yes, that's still the source. And because of the non-determinism, the notion that you, put in a spec or a series of prompt files, and then the new compiler is just running it through an AI tool, that's not really architecturally workable, and that's a futuristic conversation. Or do you see people experimenting with that?
Well, I do see people experimenting with it. It is interesting. If we sort of ignore human consumers for a second or put them on the back bench, is there a different way programming languages, let's still call them that, could look that is much better for us all for AI to use somehow? And it's possible. I don't see things that are super promising in the sort of on the big scale of things. It's likely, certainly existing languages, we now have a new kind of consumer to take into account. We say C# is a general purpose language. And so developers in all kinds of fields should be able to, like a broad set of fields, should be able to consume it and have good value from it. And now we have to include agents in when we think about our users, the users that are going to adopt a new feature and so on. That's still like incrementally evolving our existing programming languages, but for the time being, those are also what the AIs know about, right? It seems that the biggest predictor for how well an AI is going to do with a programming language is how much code was in its training set, right? It's as simple as that. It's not like, it was more functional or it had more types or whatever. We can't really tell those things. Those properties are in the noise, and whatever signal we pick up on those are not even necessarily trustworthy. They might just be an effect of a temporary thing or whatever. So, but for now, the main thing is the AI has lots of experience, not personally, but at its disposal, and therefore it does a good job. And that's going to continue to be the case for a while. That there's sort of like an incumbents advantage there for languages. Over time, that may change or it may not. It depends on how much AIs in the long run and humans end up being aligned in what's good for them or bad for them in a programming language. My working hypothesis is that for the vast majority of cases, they are probably aligned. The same kinds of qualities will help both a coding AI and a coding human in many cases. We should find the places where it's not the case and be clear about how we act with those. And we should continuously try to disprove the thesis itself that we are similar in what we like in programming languages. And there are other factors as well. But we're just going to have to kind of try our way here and keep an eye on what results are out there and what, try things, see what happens, iterate. Learn.
So let's move away from a topic where we're kind of guessing a little bit to a topic that you know exactly what's going on. with .NET 11 Beta 2 just coming out as being available and working on the C# language features for the coming. What should people know? What C# language features or enhancements are kind of interesting in your opinion for this next wave?
For C# 15, as it's going to be, the very main thing is going to be union types. That's the big new foundational feature in C#. We don't have one every time, but we do have one this time. So that's essentially having a way to express that that a given value has a closed set of possible types that it can be. And it's taken us a while to land a good design on that because there are very different concepts of unions already out there with pros and cons. Functional languages have originated this notion of discriminated unions, where you like have a tag for each kind of thing a value can be. TypeScript has been the forerunner with type unions, where there's no discriminator. It's just like this type, or this type, and you figure out a way to tell which one you're looking at. And we've sort of learned from both camps, as well as from like what will feel hopefully native and natural and in the spirit of C#, and also be efficient on our platform. So we have our own kind of Goldilocks design on this that I think is very simple and I have high hopes for. That is going to that is likely to be more associated features, but the first down payment, that like the core feature, is slated for C# 15. It's going to be in not the upcoming preview 2, but the next one. I think we're aiming to have the first version of it out so people can start playing with it, trying it out. That is huge. It really kind of not only makes your code more concise and expresses intent better, both things that AIs love apparently, by the way, but also the consuming code is going to be very convenient and highly checked, right? So it gives you a strong confidence. Oh, I know that I've checked all the possibilities. Otherwise I get an error, that kind of thing. So that's the main thing.
So instead of several method overloads, you could just have one method and pass in some number of types. And
you could. I think it's possible that people will do that, especially if the union type becomes a little bit of a like exchange type, that one that you pass around on its own. Mm-hmm. For methods, it's more likely to see unions in the result types, maybe because you can only have one result. And so you don't get to overload methods on result type in C#. So just for that reason, you'll be like, well, if I have two different possible result types, unions are the way that I can do it. I think that unions are going to be highly represented in like object models. When you model your domain and you have like, it could be this, this, or this. That's actually not that's not that easy to do in object-oriented programming. You could say, well, I have a base class or an interface, and then I have some classes that implement or derive from that, and they are the options. But you have to go through hoops to prevent someone else from adding a fourth one, like in a different assembly or something. So the exhaustiveness of it, the knowledge that there are only these three, is actually hard to express in any way in C# today. And so wherever you feel that desire, we're going to give you tools to express that better.
Awesome. Yeah, it is. It is kind of. It's not every year that one of these big features comes out that says, "Wait a minute, I did this whole inheritance tree, or I did all this other code, and now with this language feature, I don't even have to do that." Yeah, that doesn't happen every year, does it?
Yeah, and we are. So there's probably a lot of people who have hierarchies where out there that they're now like, I wish I had unions when I wrote this, but now I'm stuck, because I have, compatibility constraints or whatever. So we are doing a few things to kind of smooth the transition, if you will. One is that we are also, hopefully it also makes C# 15, we're adding another smaller feature, which is closed classes. So you can declare a class as closed, and that means that you can only in the same compilation, in the same assembly, essentially, can you derive from it directly. So it's just you're just a hierarchy like before. You can even derive freely from the derived classes themselves and so on. The only difference is you get limited to not derive from this one elsewhere. And now consuming code again can strongly check. It can strongly know that there are only these three options. It's not always three. I don't know why I always say three, whatever number it is. And so that can give you an alternative way of expressing that exhaustiveness where you still have a hierarchy. You don't have to like completely change your representation.
So would I be thinking about it correctly to say it's still public visibility, but only internal inheritance?
That's a way of thinking about it. Yeah.
Okay. Nice. Nice.
But not just,
Cool.
you can do that today with various tricks. Like you can have internal constructors
Oh yeah.
only, and then
Try
you're
to force
forcing. But that doesn't give you any guarantees that the compiler can help you with. It doesn't improve the confidence of the consuming code, if you will.
Mm-hmm.
So you only have the slap on the wrist. You don't have to pay out. Now,
Right.
with these features, you get both.
Nice. Yeah. First class citizen. Awesome. Well, as we close up here, is there anything that's been on your mind lately that listeners should take a look at, or we should point them to?
Unions, obviously. There are a few more interesting features that we are hoping to get into C# 15. I'm always, I'm never promising anything here because real things happen. I always take a look at the unions design, and in particular, once the preview comes out and you can try it out, there's still a little runway for us to make adjustments and change things that turn out to be awkward. And we're really, really excited to see it in real use and to start getting feedback from real scenarios. So as soon as you can, even now, if you can sort of discern it from what's already there, or play with the bits directly or something, would love to hear if there's something that's tripping you up, something that we kind of miss it. Now's the time to fix it. Now's the time.
Awesome. Well, Mads, thanks so much for coming back on the show and visiting and catching up. I always love your perspective, and I mean, you have such a wealth of perspective and a unique way to look at it. So thanks so much.
Really appreciate you inviting me back. I hope there will be a next time too.
Absolutely. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.